Welcome to session. Today we will discuss simple applications of refraction light. Focus on the screen. Here an observer is looking at a tank. Let O be an object at the bottom of the tank. So an incident ray OB would strike the boundary surface between water and air at B. So this is one incident ray. After refraction, it gets deflected along BC and reaches the observer. Consider another incident ray OA, which is normal to the boundary surface, and it follows undeviated refraction along AA dash, which is also normal to the boundary. Okay. So now BC is the refracted ray, OB is incident ray. When we draw an extension of refracted ray BC, it meets the line OA at point I. So for an observer who is looking at the object at the bottom of the tank, it appears as if the image of the object is formed at point I. So for the observer, the object lies at a depth which is lower than the real depth. Clear? So actually the object is lying at point O, but for an observer who is looking at the object from the medium air into water, due to refraction of light, the incident ray OB refracts along BC. So for observer, an image is formed at point I. So for the observer, the object lies at a depth AI, whereas its actual depth is AO. So AI would be the apparent depth and AO would be the real depth. Okay. Now let us look at some mathematical relations between the refractive indices of this water and air. So by definition, refractive index of any medium with respect to the first medium is ratio of sine of angle of incidence to sine of angle of refraction. So here, before we arrive at refractive index ratio, let us look at the two lines. Can you see the lines OA, that is this line OA, is parallel to BN. Okay. So line OA is parallel to line BN and OB is a transversal. So angle OBN, this angle, and angle AOB are alternate angles. So therefore they are equal. So angle OBN dash is nothing but angle of incidence I, and angle Therefore, angle AOB is also I. Now, consider the same parallel lines AO and BN. Now, the line IB, this line is the traversal. Okay. So, the angle NBC and angle AIB, these two angles are corresponding angles on the parallel lines. Therefore, angle NBC is equal to angle AIB, which is equal to angle of refraction R. Therefore, in this diagram, angle of incidence I is nothing but angle AOBI. So this angle is equal to this angle. Then angle of refraction R is equal to angle AIB. Clear? Now look at the right side. So by definition, refractive index of air, this medium, with respect to water. So first is air, second is water. So we have taken any denser medium. This is true for any denser medium. So I have taken in general as medium. So this would be sine, because the light ray is moving from denser medium to rarer medium. So angle of incidence is I, this angle. So the refractive index of second medium with respect to first would be sine of angle of incidence by sine of angle of refraction, that is R. Clear? So do we agree with this? So refractive index of air with respect to denser medium is sine of angle of incidence by sine of angle of refraction R, by definition of refractive index. Now we know that refractive index of second medium with respect to first medium, that is mu m with respect to air. So second medium m with respect to air, first medium air, is nothing but inverse of the earlier refractive index of air with respect to medium. So this I can equate to inverse of this expression. So 1 by sin I by sin R. That means refractive index of medium with respect to air, I can denote it as sin R by sin I. Let us call this as equation 1. Clear? Now, we already have shown that this angle I and this angle I are equal, like angle AOB and angle OBN dash are equal, that is I. Then angle AIB and angle NBC, they are equal, that is equal to angle of refraction R. Excuse me. So now look at the triangle OAB. O, let me rub off all the earlier marks. Okay. So now in the triangle OAB, OAB, so this is the right triangle. Now what is sin I? See, this angle is also I, sin I. So sin I is opposite side. AB by hypotenuse OB. Correct? So in the triangle OAB, I can take sin A as AB by OB. Clear? Likewise, in triangle IAB, in triangle IAB, so again this is the right triangle. So this is the triangle. Okay. In this triangle, sin R, so this is the angle R. Sin R means opposite AB. AB by hypotenuse is IB. So earlier hypotenuse was OB and now the hypotenuse is IB. Clear? So we have arrived at sin I by sin R, sin I by sin R in terms of AB by OB and AB by IB. Clear? Now, when we substitute these two equations in equation 1, so refractive index of medium with respect to air is sin I, that is AB by OB, by sin R, AB by OB. Okay, when you simplify this, AB gets cancelled, so you get OB by IB. So if you see here, what is OB? What is OB? This is OB. This is OB. And then what is IB? This is IB. So we have got refractive index of the denser medium as a ratio of hypotenuse of two right triangles, that is OB by AB. Okay. Now here lies the trick. The observer, he will observe a shallow bottom only when he looks more or less vertically, like when the point B is very near to point A. So this distance is very small. This distance is very small, delta. That means the incident ray OA and the incident ray OB, they enter the observer's eye together. So this distance AB is very small. For all practical purposes, we can think B coincides with A. So that means in that condition, OB can be taken as OA. Understood? Because for all practical purposes AB is almost 0 and B almost coincides with A, OB can be taken as OA or OB is equal to OA. And next IB can be taken as IB is equal to IA. Did you understand the logic why OB is equal to OA and why IB is equal to IA? Because these two incident rays, they enter the eye simultaneously. Therefore, the observer is almost looking at the bottom of the pond vertically while he is vertically looking at the bottom. That means AB is almost 0. So B coincides with A. That is why we can establish these two relations. So when I substitute, instead of hypotenuse, when I substitute the side of the right triangles, So refractive index can be written as, here it is OB by IB, OB by IB, that is hypotenuse. But now I will write it as OA by IA. Clear? So OA is nothing but the real depth. So this is the real depth, OA. OA. And IA is nothing but apparent depth. Okay. So refractive index of second medium is obtained as ratio of real depth by apparent depth. So we need to remember this relationship. Refractive index of denser medium is given as ratio of real depth to apparent depth. So rearranging this relationship, we can write apparent depth as real depth by refractive index of denser medium with respect to air. So we need to remember these two. Now, if you see the diagram, this was the real depth and this was the apparent depth. So the shift in depth is this one. OI is the shift in depth. So shift OI excuse me, is given as real depth minus apparent depth. So the real depth minus apparent depth, that is your shift in depth. So an observer looking from air will see a shift in the bottom of the tank by a distance equal to OI. That is why it is called shift. So shift OI is equal to real depth minus apparent depth. If you substitute apparent depth, this equation here, we can rewrite it as real depth shift is equal to real depth into 1 minus, when I take out real depth common among the equation, real depth is 1 minus 1 by refractive index of the denser medium. So we arrive at this expression. So we need to remember this. So shift is real depth into 1 minus 1 by refractive index of denser medium with respect to air. So when you look closely at this equation, what do you see? The shift depends on real depth, then shift depends on refractive index, two factors we already know. So refractive index, shift depends on refractive index, shift depends on real depth, that is thickness of the medium, two already know. Then shift depends on the wavelength of the light. So whatever the color of the light or wavelength of the light, it also depends. So this shift depends on what color of light is moving through the media. Okay, so you observe the relationship here. If we increase the refractive index, so this component will reduce. That means shift will increase. So when refractive index of the medium is greater, shift will be more. Next, if the thickness of the medium is greater, that means if the real depth is more, then shift will be more, because the equation says real depth into some element here. So if this is more, then shift will be more. Second relationship. Then wavelength. So greater the wavelength, less is the shift. In the reverse Wigor stack, so the wavelength is minimum here and maximum here. So the greater the wavelength, minimum would be the shift. So for red light, the shift would be minimum, and for violet light, shift would be max.